Question number 61. For which of the following reaction delta H value is equal to delta U value? So you should know that delta H value is equal to delta U plus delta N GRT. It means you just have to find out this delta N value for the gaseous molecule. So in the given reaction, we have to check this delta Ng value. For the first reaction, this delta Ng is equals to 0. For the second reaction, this delta Ng value, if you find out, it is minus 2. For the third reaction, this delta Ng value is equal to the gaseous moles you only have to consider here, and this would be plus 1 here. And for the last reaction, if you check here the gaseous moles of carbon monoxide and hydrogen 3 plus 1 4, while in this case 2 gaseous moles are available. So definitely 4 minus 2 is 2. So these are the value. For which reaction this delta H is equals to delta U? When this value is 0, and this would be 0 when this delta Ng is 0. And for which reaction it is so? For the first reaction it is so. And that's why I'm going to choose here option 1 as the correct option. 62 we have. When 1.5 mole of a gas is heated at constant volume from 300 Kelvin to 350 Kelvin and the heat supplied to the gas is 750 Joule, then the correct option is. Basically in the given options, if you look, Q value is given, delta U value is given, and W is also compared. So let's consider the first law of thermodynamics that says delta U, change in internal energy, is equal to Q plus W. We know this formula. And we just have to compare the values of delta U, Q and W to find out the correct option. Here one thing is there to consider, that we are talking about a gas that is heated at constant volume. And if we are talking about constant volume, delta V is 0 because volume is constant, and we know that the W is minus P delta V. So what would be the value of W for this particular case? It would be 0 because this V is 0. And yes, in this case, this delta U is equals to the Q value. And what would be the Q value here? That Q value is already given in the question, that is 750 Joule. So let's choose the correct answer on the basis of this given data. Here in the first option, Q is equal to delta U, and that is also equal to 750 Joule, and work done is 0. So this is the option that's correct. If you check other options, you will find all other options are incorrect, and that's why this option 1 is the correct answer. Let's take next question. Question number 63. When 5 moles of an ideal gas is expanded at 350 Kelvin reversibly from 5 liter to 40 liter, then the entropy change for the process is. It means we are taking ideal gas and this process is done reversibly from 5 liter to 40 liter. Then you need to find out the entropy change. And in this case, the value of N you have, that is 5 moles. Temperature is 350 Kelvin. And the volume change is also given from 5 liter to 40 liter. R value is also given. So we should know that if we talk about the S value, that is equal to NR ln V2 by V1. Let's place the values here. N value 5. R value is already given 2 calorie per mole per Kelvin. Then ln, what is V2 value? V2 value is also given, that is 40, and V1 is 5. So it can also be represented in the terms of log, that would become 2.303. This was a natural log, and now I'm just going to change 40 by 5. It would be log 8, and log 8 is 2 raised to the power 3. This value you have. And let's place the values here. 5 to the 10, and this would become 23.03 into 3 log 2. That is equal to 23.03 into 3. And what's the value of log 2? That is 0.3010. And if you solve this, you will find out this is 20.8 calorie Kelvin inverse. And on that basis, the correct answer is given in option 2. So this is answer for this question. Let's take question number 64. Question number 64. If the enthalpies of formation of propane, carbon dioxide and water at standard conditions are minus 104 kilojoule per mole, minus 394 kilojoule per mole and minus 286 kilojoule per mole respectively, then the standard enthalpy of combustion of 66 gram of C3H8, that is again propane, will be. So first we should know that we are talking about the standard enthalpies of different substances which is given, and you just have to find out the standard enthalpy of combustion of given amount of propane. So first we'll write here the combustion process for this propane, that is C3H8. It's reacting with O2. It's giving you CO2 and H2O, and in this particular process the combustion enthalpy you just have to find out. Now enthalpy of formation of these species are given here for propane, for carbon dioxide, for water also. Let's see how do we solve this question. So first we have to check the enthalpy of the reaction, and if you consider this given reaction you have to first balance it. So here would be 5O2, 3CO2 and 4H2. So this is the balanced chemical reaction, and for this particular reaction sum of the enthalpies of the formation of product minus sum of the enthalpies of formation for reactants you need. And now if we have the given chemical equation, on the basis of this we can easily find out the enthalpy of this particular reaction. So in this case we have first enthalpy of formation for the product. The products are carbon dioxide and water here. So it would be 3 into, what is the formation enthalpy of carbon dioxide? It's clearly given in the question, that is minus 394 kilojoule per mole, then plus 4 into minus 286 kilojoule per mole minus. This is for enthalpy of formation of product. Now enthalpy of the formation of reactant you also need here, and if we talk about the first one, that is propane, 1 mole is there only, that's why 1 into, what is its formation enthalpy? In standard condition it is minus 104 kilojoule per mole, plus the second thing is oxygen, 5 into, what is its standard enthalpy of formation? That is 0. So if you solve this you will find out that the value for this case is minus 2222 kilojoule per mole. We are just talking about the standard enthalpy of combustion of 66 gram of propane, not about the 1 mole. So in this case first we need to find out the moles of propane. From here we have its amount, that is 66 gram. So the moles of propane, N is equals to given mass, that is 66, divided by molar mass of this propane, that is 44 gram per mole. So this would be 1.5. So what would be the standard enthalpy of combustion of this? So standard enthalpy for the reaction for 1.5 mole would be 1.5 into minus 2222. And if you solve this you will find out this value is equal to minus 3333 kilojoule, and that's why this is the correct answer. This value that's given here, and just that's why we should choose option 4 as the correct option. I hope this question is clear to you. Let's check the next question. A gaseous mixture contains 220 gram of carbon dioxide and 280 gram of nitrogen gas. If the partial pressure of nitrogen gas in the mixture is 1.5 atmosphere, then the partial pressure of carbon dioxide gas in the mixture will be. This case, is an application of Dalton's law of partial pressure. And we know that partial pressure is dependent on the number of moles of a particular gas in the mixture. And here we have the two gases. One is carbon dioxide, another is nitrogen. So if we talk about carbon dioxide, the moles of CO2 present there are, its given mass, that is 220 gram divided by the molar mass of this carbon dioxide, that is 44 gram per mole. And if you solve it, you will find out it is 5 mole. In the similar way, moles of the gas, that is nitrogen, is equal to its amount 280 gram divided by its molar mass, that's 28 gram per mole. And that's why 10 moles are present here. And now let's consider it. The partial pressure of CO2 upon the partial pressure of nitrogen, that would be equal to the moles of CO2 upon the moles of nitrogen. So in this case, pressure of CO2 we need to find out, partial pressure divided by partial pressure of nitrogen. That is given in the question, which is 1.5 atmosphere. That should be equal to the moles of CO2 we have calculated right now, 5 mole divided by 10. Those are the moles of nitrogen gas. So it would be 1 by 2. And on this basis, partial pressure for CO2 would be 1.5 divided by 2. So that would be 0.75 atmosphere. And this is the answer that you need here. And on that basis, option 2 is the correct answer. And after this, it's a turn for question number 66.